Hi everyone, welcome to my channel. My name is Fikret. This video continues video tutorial dedicated to learning Microsoft Fabric. In the last video, we got familiar with core components of real-time analytics service workload in Microsoft Fabric. So we learned what is event stream, what is KQL database, and we created simple ingestion pipelines using each component. If you haven't had a chance to watch that, I would encourage you to take a look because today's sessions is built upon that video. Today we are focusing on event stream transformations. We'll take a look at different type of transformations, including some column transformations as well as some table and aggregate transformations that are available in event streams. Here's a quick preview of what I'm going to cover today. I will start with the discussion of architecture options when it comes to transformations. So there are different options. So you can either do extract load transform or you can do extract transform load. So event streams allows you both. So I'll explain differences between this approach. Then we'll talk about different event stream transformations that are available in Microsoft Fabric. In a demo section, we'll create an event stream which will ingest sample data and will write into 4 different destinations. So I'll apply different type of transformation for each destination. Some of them will be detailed transformations like column level transformations. Some of them will be aggregate transformations. Before we continue, very briefly, I want to thank everybody who has subscribed to my channel. Your support helps me grow my channel and it means a lot to me. Let's have a quick discussion around architecture options when it comes to ingestion and transformation using event streams. So I think there have been 2 popular approaches when it comes to any cloud ingestion. So that's extract, load, and the transform approach, where you bring the data to your cloud as is with minimal transformations, and extract, transform, and the load approach, which includes some transformations on flight before your data arrives to the destination. So the diagram here represents the first approach, extract, load, transform. With this approach, you can build event stream pipeline which can ingest from different data sources. So I mentioned in the previous video that you can ingest from Azure Event Hub, Azure IoT Hub. You can ingest from custom application as well. It's not displayed here, but that's another source. And then you can bring this data as is to either Lakehouse or KQL database. And then you can use transformational engines of this platform to do further transformation. So for Lakehouse, you can use either batch Spark APIs to build batch pipelines, or you can use Spark streaming, structured streaming APIs to build real-time low latency pipelines. So when it comes to KQL, you can use powerful KQL language to transform, visualize, and write in the different destinations in KQL database. You can also write results from KQL database to Lakehouse, and then you can, once your data is curated, you can use different reporting tools to connect to SQL endpoints either in Lakehouse or KQL and ingest the data from these endpoints. Advantages of this approach is that it follows medallion architecture principles, which recommends that you bring the data to bronze layer as is with minimal transformations. It also allows you to archive your original data, so you can keep adding your data and take care of transformations later. And if for some reason your transformations need to be re-engineered, you can easily come back and change this part without worrying about ingestion part. That also means that your pipelines will be probably more resilient, because you will not have interruption in your ingestion part, even if your transformation logic may change. Having said that, I should also mention that when you are using event stream, for some data sources, your data format will probably change. So that's what we have seen when we ingested from event hubs, where we had JSON data, nested JSON data, which has been flattened while we were trying to ingest using event streams. Now let's talk about another popular option, which is extract, transform, load. With this option, you can include some transformations within event stream pipelines. There are not too many transformations that you can do within event streams, but given that this Microsoft Fabric is still young, I would expect that in coming months and years, so this transformations list will grow. The beauty of this option is that it allows you to build pipelines, streaming pipelines quickly without doing any coding. So everything that is within event streams are really easy to understand and intuitive. So what kind of transformations you can do with event streams? First of all, you can do wide range of column transformations. You can do column type, data type conversions, and you can create calculated columns using rich set of built-in functions. So there are some string functions, so date time functions, some numeric functions, which we'll be exploring a little later. You can also apply filters. And then there are aggregations, transformations. There are two aggregations options with event streams. The first one is called Aggregate. It allows you to calculate aggregations based on certain column. So you can include maximum, minimum, so you can include multiple aggregate functions. And this aggregates will be applied grouped by certain one or multiple columns, but in addition to that, you have to specify time interval. So it's basically entire time will be split into different time intervals, which you can specify length for, and this aggregation will be calculated at the end of each snapshot. The second aggregation transformation is a GroupBy transformation. It is very much similar to aggregate transformation, but it's more flexible. So it also allows to adding multiple aggregate functions, but in addition to that, it allows you to choose window types. So GroupBy transformation allows following types of windows. So that's tumbling, sliding, hopping, and the session. There is a good Microsoft documentation describing the difference between these windows. Let's take a close look at that. So the tumble window is, I would say, probably simplest type of window, where you have no overlap between windows. So you can see that length of window is same as frequency of the window. So in this case, 10 seconds window. Another common type of window is hopping window. which is overlapping. So in this case, your window length is longer than frequency of window. So in this case, we are talking about 10-second window, which triggers every 5 seconds. So these two event types are not event dependent. That means that you basically define the duration and frequency, and whether or not events happen, these windows will trigger. There are some other window types. For example, sliding window, which is also overlapping window. However, it's dependent on the event. So if there are no events during some periods, there will be no window. So this is the gray box here represents absence of events. And there is another event-based window, which is session window, which I think is less common. So I will let you explore this article and we'll come back. The last transformation type that's available in event stream is a union transformation. It allows you to merge output from multiple transformations within the same event streams. Let's jump into the demo section. All right, I'm in Microsoft Fabric's homepage and I selected real-time analytics workload. Let me start by creating event stream. I'll assign the name. Now let me add a source. So this time I'm going to add sample data. So I will select stock market data and I will name my source. Event streams allow you to add multiple sources and destination. However, in terms of source, the structure should be same. Now I'm going to add multiple destinations to demonstrate different types of transformations. All of them will go to KQL database just to keep it simple. My first destination will be for detailed data. So I'll select KQL database, will name my source. We'll select my workspace, KQL database that we created in the previous lesson. And for destination table, you may need to refresh sometimes. So in this case, for some reason, it wasn't able to see the data sample. Now I can use create new table and name my table. I'm going to name it and then I'll open event processor to add transformations. So design page will have two nodes at the beginning, source and the destinations, and you can add as many transformations in between as you want. The first transformation that I'm going to apply will be data type conversions. So if I select my source, on the right hand side I will see panel with data type. So let me minimize this, and here you can see data types against each column. So ABC means string, and this small icons means date timestamp column. So from the quick glance, we can see that some data types are incorrect. So for example, I can see the bid price is and bid size as string. So if I take a look at the data, bid price should be decimal, bid size is integer type. So let me change this first. So I'm going to select bid price and click on three dots and select data type. And from here, I'm going to select float. Similarly, I'm going to change bid size. As I change my data types, and select my destination. Now I can see that these new types are reflected on the destination. So data type transformation do not require adding transformation nodes. So I would call it in-place transformations. Next, I'm going to apply another common transformation, which is calculated column transformations. I'm going to select my source, and if I hover on that node, I'll see plus button. I'll select managed fields transformation. And here I can add all the columns using add all fields. So let me first use this. And then I'll add individual columns. So if I click add field, I can open this window which presents multiple options. So imported schema is a folder that will contain all of your fields. So you can bring all the columns from here. And then you have 3 categories of functions. Let me expand datetime function category. So under that I have system timestamp, which allows you to add ingestion timestamp, and there are some also datetime functions that allows you to extract certain parts of your timestamp column. So let me add this column first. So this will represent my ingestion time. I can change the name as needed, but I'll leave it as is. Let me add a couple more transformations. So I'm going to extract day and month components from event time column. So I'll use add field. From here, I'll expand datetime function, and I will select day, and I will select my time function, time column. And then I'll name this column as, and we'll add one more column. Then I'll confirm my manage fields transformation by hitting done. So if I select my manage fields and take a look at the data, now I have event month, event day, and this current timestamp added to my data. Another common transformation is a filter. So in my data, I have a sector column. So I might want to split my streams and write each sector into different table. So I can add filter transformations from here, just like I did for manage fields, but I'll show you different methods so that to demonstrate how to handle nodes, so transformations nodes here. So I'll use a filter transformation from here. Whenever you add transformations, it normally is added outside this chain, transformation chain, but you have to link this transformation to your full transformation chain. So let me bring it here, and I'll remove this link and build a link between these two. So output from my manage field will go to filter, and let me rearrange my nodes. And then I will link my filter to my destination node. So let's say I want to filter sector field, and the conditions I'm looking for is equality, and then I will scroll down and I'll put exact value here and hit done. Okay, so if I select this node, I can see that my data have been filtered correctly. Another type of detailed transformation is expand. It allows you to take array. So if you have a field with array type, and explode your data set. So in other words, create a new row for each value in that array. So unfortunately, my data doesn't have this kind of columns. I'll just confirm my pipeline configuration and finalize this data flow. And then I'll hit add button to complete this stream, event stream. So once destination is added, it will normally take few minutes to get end-to-end ingestion running. All right, now that my detailed destination ingestion is up and running, let me add another destination, this one for aggregate transformations. So I'll use the same process to write in the KQL database. I'll name this table as stocks aggregate, and then we'll open event processor to add my transformations. Before I add aggregate transformation, let me fix my data type issue. So I know that my data types are incorrect. So let me select my source and then come to bid price and change my data type. I'll just change few columns. Next, I'm gonna add ingestion timestamp, which hopefully will help me to interpret my aggregation data in the destination. So I will just hover on my source and add manage fields. And I will include all the columns from the source. And then I'll use add field button, just like with the previous example, and I'll select system timestamp. I'll leave the destination column name as is. Oops, sorry, I forgot to hit add button, and it reminds me that my configuration for this transformation wasn't complete. Okay, now I can add aggregate transformation. The easiest way to do is just to select the node after which I want to add my aggregate. However, I want to show it different ways this time around. So I'll select operations, and from here I'll select aggregate transformation here. So when I use this method, this node is added separately, and then I'll need to connect it to my data flow chain. So I'll just rearrange my nodes. We'll remove this link, and we'll create a link between previous node and link to the next node. Now I can configure my aggregate transformation. There are two aggregate transformations in event stream. The aggregate transformation is the simplest one. So once you selected that, you need to select aggregation function. So let me minimize this panel. So I'll need to select aggregation. Let's say I'm looking to get maximum of bid price grouped by symbol, stock symbol. Then you need to specify aggregate length, window length. So what will happen is that these aggregations will be grouped by, but that aggregate will be calculated not for entirety of the event stream, rather for each window period. So I'll just leave it 5 seconds and confirm add. Now I can go ahead and add another aggregate function here. So I'll use minimum this time. I'll use the same field, and I'll just use same group by expression, and hit OK. So now I can confirm. With this, my pipeline is ready. I can take a quick look at my data at destination. So I have maximum, minimum. Once I have some data in my destination table, I will explore the data in KQL, which I find it's easiest. So for now, I'll just hit done, and that will complete my second destination. So while this is running, let me add another destination. This one is going to be KQL as well. So I'll call this KQL GroupBy. So this one will demonstrate GroupBy transformation. Okay, so let me change my data types for this source as well, because I'm gonna use the same columns for aggregations. And I'm gonna add aggregate GroupBy transformation directly to my source here. So there are lots of similarities between GroupBy and the aggregates. However, GroupBy transformation is more flexible. So I'll start by aggregations, so where I have to specify my aggregate function. So I'll use maximum and I'll select bid price. So I'll add this. I'll also add count. Then we'll specify same column. Finally, I will aggregate using minimum function. Oops, wrong button, sorry. Okay, so I'll add this. So as you can see, we have more aggregate function selections here. So if I click this, you will see percentile, standard deviation, and so on and so forth. I'll just discard this last transformation. I don't need that. And then I will proceed with the next set of settings. So just like with aggregate, you have to specify a column on which you want to group by. So in this case, it makes sense to select symbol, stock symbol. However, unlike aggregate, you have different time window choices. So if I expand this, you can see tumbling, hopping, session, sliding. So for now, I'll just select tumbling window and I'll select 5-second duration. So offset is another way of adding flexibility. By default, when you specify windows, events that are at the end are inclusive, whereas events at the beginning are excluded, but you can change that behavior using offset parameter. So I'll just confirm my configuration and I'll take a look at my data. So as you can see, we have aggregate columns added to my data, and then we have window and timestamps. So unlike aggregate transformations, group by transformations actually aggregates the data. So you can see that all the detail level transformation columns are gone. Now this works more like traditional group by aggregates from programming languages. So I'll just confirm my design and hit add button to complete the next destination. One last transformation that I want to demo is a union transformation. So for that, I'm gonna add another destination here, and we'll call it KQL union. So the union transformation allows you merge different data flows within your transformation design. So let me demonstrate that. Let me add this group by and the aggregate transformations. I'll just change my data type and we'll apply aggregate first. And I'll select maximum bit price, group by symbol, and we'll just add another function. I'm going to add minimum as well, so that it will be easy to explain. Now I'm going to add group by. Okay, so let me just add group by after my source. Okay, so if I take a look at my data, group by data, so I have maximum bid price, minimum bid price, symbol, and if I take a look at aggregate, we have same columns but more columns. So when you union these two data flows, then only common columns will survive. So let me just remove this link and add union, and I'll just bring another link to my union from group by. Now if I select union, you can see that only common column names are at the end of this transformation. So I'm going to just add this to my destination and hit done and just confirm my configuration. Okay, I'll let this event stream to run for some time and come back and examine data in KQL database a little later. All right, my event stream has been running for some time. Let's take a look at the data. I am in KQL database where I ingested my data, and I created 4 simple queries to browse the tables. To remind you, stock details had detailed information. In stock aggregate, we had detailed information plus aggregate, and group by had fully aggregated data, and stock aggregation has both of them. So I can select all of them together and run at once. So that's one convenience. And results will go into 4 different tables, so I can easily switch between these tabs and review the data. So my first data is stock detailed. I have time column here and all the other columns, and I also have few calculated columns like event day, event month, etc. So now let me switch to the second table, which is aggregate data. Here I have maximum and the minimum for bid price, alongside with all the detailed information. Okay, now let's take a look at the GroupBy transformation results. Here we have only aggregate data, so no details information, and we have symbol which we used for GroupBy clause, and then we have maximum, minimum, and count for bid price, and then we have window end time. So this is system generated column, and if you compare different rows for the same symbol, you will notice that there's 5-second difference between them. Finally, my last table contains results from union. So union between GroupBy and the aggregate. It contains common columns from both tables, because we had maximum bid price and maximum and minimum bid price and the symbol for both GroupBy and the aggregate tables. That's what we see here. So each row will be duplicated here because they will come from two different sources. So that's what union does. Basically, it merged two data sources. All right, now let's take a closer look at the data and try to correlate these two different pieces of information which are interrelated. So on another tab, I have created slightly complicated versions of each query. So my first query filters on GroupBy table on particular symbol. So I just picked one random symbol, and I have additional filters to filter out only a couple of windows, and then I order the data by window end time. So here's what the results show. So it's just two different intervals. And my second query brings us detailed information for the same window. So you can see that my filters is almost identical, except here I don't have window end time column. I am using this current time column, which represents ingestion timestamp, and I basically provide same time interval. And here I had to convert bid price to double so that I could order by that price. And then my third query is also similar, so it also applies the same kind of filters and orders by time. So let me run all these three queries at once. If we take a look at the first row for this particular window between 23, 46, 30 seconds and 35 seconds, we have 33 rows. We have maximum of $410 and a minimum of $270. So if I take a look at detailed information for the same period, then I'll see 33 rows, and my price, bid price, is maximum, you can see, is 410, and if I scroll down I can find the minimum value, which is $250. And my third query has aggregate already inside this table, so it's kind of combination of aggregate and detailed information. So for certain rows we have same maximum and the minimum, so that means that they belong to the same snapshot. and then at some point these values change. I tried to correlate this to current time, so this time column that's included in the sample data actually represents current time. So I tried to correlate this to this window, so maximum and the minimum columns. I find it a little tricky because it's unlike to group by results. We don't have window start end time. So that makes this correlation a little bit trickier. So that concludes today's discussion. To recap, we have looked into different architectural options when it comes to ingestion and the transformation. We also learned different types of transformations available in event streams. Thanks for watching, and I hope to see you in future videos.